Okay.
Okay. Can we, before we get started, if each of you could introduce yourselves and tell me what your um, what what your responsibility on the project is, and then we'll get started with the overview.
Okay. So good morning, everyone. My name is Ari Kumara, and I am the team lead for the UTM rocketry team. So if we can have everyone come to the center of the camera, please. Closer.
Test, test. Am I audible, sir? Okay. All right. Good morning, sir. My name is Tahe, and I'm basically in charge of the propulsion team. Yep, I'll pass to the next person.
Good morning, sir. My name is Sufyan, and I am charge of aerodynamics team.
My name is Shiv Prakash, and I'm in charge of the avionics.
A very good morning, sir. My name is Amir Hakim Mirzal, and I'm in charge of the rocket's recovery system.
Okay.
Good morning, everyone. So I'm Angela, and me and another person, Yusuf, is in charge of the structural.
Okay.
Okay, I think there will be all our members joining in for today's meeting.
Okay. And the fire of record.
Yeah, that's me, Julian Chi.
Okay. All right. Um, okay. The way I like to do this is um, start with the fins and work our way forward. We need to look at the rocket as if it was right in front of me, so I can see the construction and the parachutes, the shock cord, all that sort of stuff. We want to look at the electronics bay and the wiring, the batteries, and so on and so forth. Okay, so let's start with the aft end and the motor retention and go from there.
All right. Good morning, sir. So I'll be just briefing through the entire motor selection and also the motor retention.
Bring the camera closer.
Okay.
Okay. You need another phone for the camera.
Yeah, I want to be able to see the
Let me try
actual
to.
rocket.
Oh, all right. Okay. So basically, first and foremost, our chosen motto for our entire rocket is M2500T. Among all the considerations, among all the variables that we were seeing, we were mainly considering the burn time and also the average thrust of the rocket, which is around 2,500 Newton, and also the burn time for
Yeah,
3.88
the
seconds.
whoa,
Why is
whoa,
this
whoa,
so? Because we have
well,
considered the
let
weight
me
of our
stop,
entire
stop,
rocket and
stop. Yeah, stop. Okay. Number one, please slow down. Number two, I can barely hear what you're saying. So,
oh, okay. Two phones. All right. So give us
and
a.
I need to actually see the rocket, not the person. And I'm not sure where all the feedback was coming from.
Can't hear you.
Do we have multiple cell phones going? We should only have one cell phone. We're getting a lot of feedback.
Uh, Testing. Sir, am I audible?
Nah, that's a lot better.
Okay. Um, do give us a minute. We'll try to get a close-up camera. Okay.
Yeah, that's fine. I totally understand.
All right. Thank you, sir. Thank you so much. All right, it's good. Okay, so sorry, I'll restart it again. Okay, first and foremost is our motor selection. We have selected the M2500T motor, mainly considering its average thrust and also the burn time. So basically, we have considered the entire weight of the rocket, and to achieve the apogee for 10,000 feet or closest to it, this motor brings us the closest to it. And we have done a sort of like a motor screening for so many different types of aerotech motors, and yeah, this is our best option. Now coming to the structural part of the entire motor retention, first and foremost we have the motor tube where the motor casing will go in. Okay, so all right, here is a motor tube. We have 3 centering rings to hold the motor tube in place. 2 are sandwiching the fan, and 1 more is towards the end of the motor tube. We have on this side. Okay, there is the centering ring inside. I'm not sure if it's clear. Yeah, all right. Okay, and towards the end, we do have the thrust plate. Okay, the thrust plate is basically to transfer the entire thrust to the rocket body itself. And once we have inserted the motor, we have the retainer. Okay, so maybe I'll just demo on how we can assemble the motor to the system.
Okay.
The shortcut. Okay, a little bit. So you can do this. So it slides in just like that, and we have the retainer that goes in. Sorry, it's a bit tricky. Oh,
Okay, that's
no wonder.
Okay.
Okay.
Good. Okay.
All right. We have the
All right.
retainer here, and then we'll put the screws and nuts for all of these
Gotcha.
4 threaded rods. And that's how we actually
Okay.
retain this entire motor in the motor casing and the motor tube.
Okay.
So this is
Very
basically
good.
for the motor. And moving
Okay.
forward to the front part of the forward closure, we have already inserted an eye bolt. This eye bolt is connected to the shock cord for the secondary chute. And I think
Okay.
that's basically it from the motor and its motor retention. Is there any questions, sir?
No questions on that. Explain how your fins are attached and a little bit about your fins.
All right, sure, sir. I'll pass it to our aerodynamics.
I'm interested in how they're physically attached. I'm not necessarily interested in the
Okay,
aerodynamics of that.
so we have cut all the fin slots right now, but since we are traveling, we have not epoxied the fins yet. The fins will be epoxied to the motor tube at the bottom, as well as to the body tube outside. Then we'll have a fillet of epoxy here to make it smooth. And also, there's
Okay.
like the fins are sandwiched between 2 centering rings in the front and the back. These will be epoxied to the fins as well. That's
Okay.
basically all for the fins.
Okay, so you don't have the fins physically mounted yet. You need to go back and do that, correct? Whoa, somebody's got another phone on.
Okay, pass it to you.
Okay, so the fins have not been physically mounted yet.
So basically, sir, we haven't mounted the fins yet because we will have to ship this thing to US. So we are a bit concerned on how we're going to. I mean, we don't want the fins to break. Yeah. So we will be epoxying the fins once we are back in US.
Okay, that makes
You're only
okay.
gonna build the aft end after you get here.
Basically, everything is already built. Everything will be epoxied already. So only the fins is the one that will be epoxying it in the US, because
How
since
you
it
going?
sticks out, we are afraid.
How are you going to access the inside? You need to epoxy the inside, the root of the fin. You know, if you close everything off with your thrust plate,
Yep.
if you close everything off with the truss plate, how are you going to access the inside?
Okay.
The inside, after we remove everything from this, actually we will epoxy the roots and the sides for this when we are enter it inside, and we can get like a stick when removing one of the parts from the motor and epoxy from inside.
That's a lot of work to do just a few days before the competition. I suggest you build it at home. I suggest you build it as soon as you can and then figure out a way to protect it. It's not going to break on the way while it's being shipped. If it's going to break while traveling, then it's not strong enough to fly. That's my opinion.
I won't argue with that. You know,
Yeah, okay.
You can just get those.
because and secondly, it's going to take the epoxy at least a day or two to cure. Also, so depending on when you plan on getting into the States and setting yourself up, you're going to have to come in well before the contest in order to make sure that was physically done.
Yeah, and when it's drying, when the epoxy is drying, it has to be in a certain orientation. You can't just put the glue and then rotate it, put the glue again, then rotate it. It doesn't work like that. So
Yeah.
just do everything back home first.
Do you have a fin jig that you can use to make sure the fins go on
We are
straight?
using fin. We're using fin guide to for epoxying the fins together. So like we made
Okay.
our own using like plywood from laser cutting it, and then we insert it to the fins, and then we epoxy based on this. But there should be another one like this. So there's two, and they're connected together, and it will enter the fins and make them stable. Then we can epoxy after that.
Right. Okay. All right. I'll let you, okay. However you decide to, whether you ship with the fins or without the fins, that's sort of your decision on how you want to do with it. I agree that they need to be attached through the wall to the motor tube, and that needs to be glued in place. So, however you can do that, you need to do that. For the rail button, the aft rail button, where's the aft rail button going to go?
One on top of the center ring. Wait.
You just hold it.
Yeah.
One of the red buttons will be on the center ring of the motor tube, and the other one will be on the next tube above.
Okay. Generally, it would be my suggestion that the aft rail button be further back as far as you can get it. Um, Not at the top of the fin, but at the right where that thumb is, um, around that area there. But where you're planning on putting it is also fine. So either way will work.
So we can attach on the two center rings, right?
Yeah, it needs to be hard mounted into something. You can either have some sort of a backing on the rail button, or you can screw it into a uh, centering ring like you're doing there, and that's fine too. Okay. All right, let's go to the front of the motor and talk about that. Uh, Talk about that U-bolt that's there. Not U-bolt, but talk about that eye-bolt that's there. How are you going to make sure that eye-bolt doesn't come unscrewed?
Okay. Um, Okay, so basically, the eye bolt is we got a thread that covers the entire forward closure, and from our testing, it's already pretty tight. We have the shock cord here, and by our previous testing in the lab, it shows us that it's pretty solid to say, like it's fixed quite strongly. Yep.
You have a split
Okay.
washer or anything stopping it from backing out?
Yep.
At least put some Loctite or a swivel.
Understood.
Correct.
Maybe we will.
Yep.
Yeah,
Yeah,
sure.
just
We'll take it into account.
yeah, you can put Loctite over it and then don't touch it. Put Loctite, split washer, swivel, the whole combo. And once you put it, you kind of don't have to touch it. So I suggest doing that.
Okay. While we're there, that shock cord, what kind of shock cord do you have?
Okay.
Looks pretty thin to me.
Right. Hello, sir. So I'm going to be explaining a bit about the shortcut. So the shortcut that we'll be using is a 9/16 inch in width tubular nylon shortcut. And for each section here, as you can see here in the droop and the main section for each section, we'll be using around 42 feet in length of the shortcut. Right. And at the end here, at both ends, one will be connected to the motor section and the other one will be connected to the avionics section. So on both ends, we made a figure 8 loop. So just to make like a hook section so that we can connect it with the respective bulkheads by using 8mm quick links, as you can see here. And then if we go all the way to the middle, where the dock chute is actually connected, right? We made a loop by using a butterfly loop, if I'm not mistaken. And at loop here, we connect it with the dock parachute by using a jaw-to-jaw swivel, a 10mm jaw-to-jaw swivel, as you can see here. Yeah.
Okay. All right. Let's go back to the motor where you connected it to the motor.
Yes. Okay. All right.
Okay. And you did basically a loop over and a knot of some kind.
Yes, sir. A figure eight knot.
What's the okay? Your shock cord is rated. What's the rating for the shock cord?
If I'm not mistaken, it should be around what was it? 3,000 pounds, if I'm not mistaken.
What's the rating when you tie a knot?
Ooh. Can't.
Okay. Okay. Number one, I don't have a problem with knots. Okay, but
Yes,
when you go through the convention center and we do the final review, you're going to have off the tip of your tongue what the rating of the shock cord is and how the knot affects the rating of the shock cord. Knots generally reduce most shock cord ratings by about 20 to 30%. So if that's rated at 2,000, it could very well, with a knot, now be rated at 1,600. Okay.
All right, noted with thanks, sir.
Okay.
What's
All right.
that? What's the quick link made out of?
It would be stainless steel, SS316, Julian.
Okay.
Yeah.
Okay.
Okay.
Both the quick
And
links and the swivel made out of the same material.
out of curiosity, do you call it a quick link or do you call it a Caribbean?
So at least in our circle, we use the term quick link.
Okay. All right. It's a little different. Looks more like a Caribbean to me, but that's okay. No problem with that. All right. Let's okay. So you said the length of your shot cords were how long?
For each section, we're using around 42 feet.
For the apogee and for the main section?
For the pardon? Oh, yeah. For both sections, yeah.
Okay. Since it's exposed right there, can I see your altimeter bay?
Oh, altimeter bay.
Or your slit? Yeah, that right there.
Yeah.
Okay. Is it finished?
Yes, it's finished. We have connected everything except for the screw switch. We haven't soldered it yet because we haven't finalized the holes yet. Like haven't drilled the holes yet. But other than that, it's
Okay.
all connected. We'll be using lithium ion batteries for the altimeters. And for the GPS tracker, we'll be using the lithium polymer battery that's provided by Featherweight.
Okay, so we require two altimeters. I only heard one. Are there two altimeters?
Yes, there's two. One is the main altimeter is a Blue Raven. Our redundant altimeter is Easy Mini, Altus Easy Mini.
Okay. All right, rotate it back to where it was. The wiring needs to be cleaned up. It can't be
Yes.
strangling. Okay. Everybody says yes. It better be when we get to the contest. Okay, rotate it over. Well, explain how the batteries are going to be secured and held in place.
So during after we finalize on the battery, like we recharge it and all, we will be using electrical tape and be crossing it over the two segments of the battery holder.
Tape.
How how is it? How are you going to uh, uh, electrical tape just across? If I understand, things won't work. Won't hold it in place. And are you going to? Is it going to be full length and come underneath the the connection you got there, or just across the top, or what?
As of now, we thought it was just across the top.
That won't work.
Okay.
Dude, can you flip it over?
Yeah, there's a little lipo battery sitting there too.
Yeah, it's which direction it's flying in the antenna pointing up, right?
Initially, we did it antenna pointing up, but it was how to say?
Okay, the Blue Raven is not necessarily oriented. It will figure out what orientation it's in, but
Yes.
nevertheless, so I, if I was doing it, I would move the GPS transmitter away from the Blue Raven and maybe up a little bit on that end of it. So, okay, the batteries have got to be secured.
Okay.
They're what you've got now, and a simple piece of tape across the top will not work. So flip it back over. My suggestion would be to figure out some way to get some tie wraps that go through that basically go all the way
Yeah, zip
around
tie it.
zip tie them. And I would probably put two zip ties per set per batteries. In other words, one, basically two of them evenly spaced apart. Does that make sense?
Yeah, understood.
Okay. The other thing is on those batteries. Is there a spring that holds those batteries in place?
Yes, there's the springs holding it. It's pretty tight for us to remove it itself.
Yeah, tight. Unfortunately, at 14 or 15 G's, tight
Yeah.
don't mean too much. At least they're going that way. If there's any way that you can make it so that it's very secure, so those batteries can't move either sideways, up or down, or pop out, then you need to put some work into that and clean that up a little bit. And a lot of the problems with batteries aren't necessarily on while the motor is thrusting and moving forward. It's when you start deployments and you get the jerking back, and that starts to work batteries loose and all that sort of stuff. It's also a good idea to put your electronics on one side and your batteries on the other side. That way, if a battery comes loose, it doesn't destroy the electronics. The way you've got it there, if one of those batteries came loose, it would destroy that mini that's sitting there. So it's up to, it's up to you. I see both of them. I see electronics mounted right next to the batteries. It's my recommendation that batteries be on one side, electronics on the other side, but it's not a hard written rule by any stretch of the imagination. So I'll leave that up to you. Okay.
All right, we'll take
And okay, and also, like I say, clean your wiring up. Shouldn't be dangling and all that sort of stuff. So okay.
Okay.
If you're going to 3D print it again, you can include channels so that you can run your wires through. That way they don't make a mess.
Yeah. Yeah, I mean, you got a lot of flexibility with 3D printing. I mean, not only can you do what Gina's suggestion, you can also print your standoffs and do all kinds of neat things with 3D printing. And there's nothing wrong with the sled being the full length either. So, but that's kind of up to you. Can I see the bulk plates and can I see the charge wells? How that's going to look? So rotate that around. Do you have your charge wells installed?
Hello. Okay. So sorry, sir, but unfortunately at this time we don't have the charge wells installed at the bulkhead. However, we already, as you can see here, we already made the hole for it, and the charged wells themselves and the black bar there is already been tested and been by tests, and it seemed to be working fine from our tests lah. And so it'll be fixed here at these two spots here, one for the primary charge and one for the secondary charge. We'll primarily be using 20 millimeter PVC caps, which will be screwed into the avionics bulkhead.
Okay. When do you plan on charge testing this?
Oh. Okay. Pardon, sir?
When do you plan on doing your charge testing to make sure your charge sizes are correct for deployment?
Okay. Hang on, sir. So here we'll be showing a video of the charge test themselves.
That's not what I want to see. What I want to see is the rocket configured and the charges go off and the separation occurs. I don't want to see the charge standing alone by itself over there. That means nothing to me.
So just to double check, so what you're saying is, what you're asking about is when are we scheduling to do the ground test, is it?
Correct. Because obviously you don't have the charge wells mounted. That means you have not completed your ground test. You haven't even started your ground test yet.
Yes, sir, not yet, but we are planning to do that sometime next week. We're just waiting for most of the other parts to be finished yet, to be finished first.
Okay, sometime next week. Did I hear?
Yes, sir.
Okay, and you'll be testing your black powder charge sizes, your ground test.
True.
Okay. Okay, what's the diameter of your airframe?
The diameter of the airframe, it's around 6 inches. Yeah.
6 inches. Have you run any charge size simulators to see what size of charge you're going to need?
So by using external resources and also some calculations that we did on our own. So for the primary charges, we found the value to be around 3 grams for the primary charge. And so just to up it a bit for the for the backup charge. So it'll be around 3 grams and 4.5 grams for the primary and secondary charge respectively. That's for the main section.
Okay. All right. Yeah. The backup charge should be anywhere between 1.5 to 2 times the size of the primary. So your 2 and 4, or a little more than 4, is perfect. Okay. All right. So
You're going to need to redo any ejection charge test once you arrive, especially if you're not using the same batch of black powder. So whatever test that you do in Malaysia is just to ensure that it can separate, cleanly separate. But when you arrive here, I want to see another one before it flies.
All right, Julian. I know that.
Yeah. Yep.
okay, well, you will have we'll have an area at the contest where you can charge test. Please don't charge test outside your hotel room or your Airbnb or whatever. Okay. All right.
All right, so we'll do.
Okay. All right. Okay, can we go back and let's look at recovery real quick and show me your parachutes, your drogue chute, and your main chute, please?
So let's start with the main chute first, right? As you can see here, it's actually already been included in a deployment bag, and it's already wrapped, fully wrapped, as you can see here. Right, with the bottom here, actually, we are being connected to a pilot chute, a 14-inch diameter pilot chute.
Okay.
So, would you like me to actually take out the parachute from the deployment bag, or is it okay? That's
No,
it?
I'm just what I'm really curious about is if there are any burn holes or anything, or, any tears in the chute at all.
So far, there doesn't seem to be any.
There doesn't seem to be, or there are not any.
There aren't any, as far as I understand.
Okay. It's the same for the drogue?
Yes, sir. Yeah.
Okay. How much experience do you have using a D-bag and a drogue to deploy the main?
Frankly speaking, this will be our first time, sir.
Okay.
Is there a pilot chute on the back?
Yes, sir. Is it a pilot chute?
Yeah, they have a pilot chute.
Can I see?
Yep, exactly.
Oh, that's the pilot chute?
Yes, connected to the bottom of the, what's it?
Yeah, that's fine. Yeah.
Yeah.
Yeah, that's fine. Yeah, that's fine. It takes a fair amount of experience to get deployment bags and their pilots and everything to work correctly. So, best I could say right now is good luck on that. Okay. And the drogue chute, it's in good condition.
Yes, sir. Just the same as the main parachute.
Okay.
Is that from Fruity Shoots?
Yeah, the one that we'll be using.
They're both fruity shoots. Okay. All right.
Yeah.
All right. So let's now go to the airframe itself and talk about the separation points and also indicate coupler links and indicate shear pin sizes, number of, and so on and so forth. So show me separation points, hard points, etc.
Okay, so this is our main airframe.
Okay. I think we just lost the audio.
The shear beds. Okay,
Pardon?
so the separation points.
Yeah.
Which parts is going to be separated from the avionics?
All right. So we have 3 components here, right? So the shear pins themselves will be located here, as you can see in the holes here, right here.
Okay.
That's for the top section. Yeah. So it'll be inserted in and separated whenever the deployment charge is engaged. And then for the motor section, the shear pins will be located here. We put like temporary screws here. Here, then. Oh, my bad. Yeah, over here, the shear pins. On that part.
Here should be the shear pins.
Yes.
Okay. So between his hands at that joint, is there a coupler there?
Is there a coupler there?
Yeah.
If you pull those two sections apart, is there a coupler?
Yeah, there is a coupler.
Can you pull it apart?
It's screwed on out.
Screwdriver? Screwdriver. Yeah.
Is there a nut on the other side of the coupler?
Yeah, we're planning to use a nut, but this is now for testing. We're not using a nut. But we're gonna epoxy nut from the other side. This now is only threaded through the tube and the cover. And after the testing, like which was being done already now, we are gonna epoxy a nut below the coupler's wall, and this should be fixed. Then the bolts itself can come in and out. But for the shear bends, there are gonna not be any.
Yeah, you don't
anything
need it for
that's
shipment.
just the thread itself. Yeah.
That's where the AV bay goes, right?
Yeah.
This This is a screw switch.
Yeah, make sure you mention that, the top section of the AV bay doesn't go in one coupler length. I mean, one, what do you call that? Yeah, the length of it is a little shorter, but it's not separating. It's you're bolting it in, right?
Yes.
The top section. Okay.
Okay, so that is a non-separation point. Above that is the separation point. Oh, I see is that your switch band that I see?
The what?
That?
Yeah.
Is that just, okay, just pull the tube off to the right. I don't need,
Pull the tube off to
I want to see it. Yeah, pull that, there you go. Pull that one off.
this one.
And your shear pins will go in that tube?
Yeah, and here. The place where I unscrewing that. This is the place of the shear bed. Like the below side to the screw switch.
Is it not backing out? Why does it take so long?
It's pretty tight. But it's backing out nicely.
But buy an electric screwdriver. This is super useful.
Yeah.
Yeah, it's in the lab.
Come.
So just to give the team a heads up, the questions I'm asking and what I'm asking you to do, you'll also be asked to do exactly the same thing when you get to the States. So I'm not, okay, there we go. Okay, now, all right, so, okay. So that's section, all right, so your switch band is where your thumb is?
Yes.
2 inches.
Right.
This is
That's the switch band. Okay. All right. So the section above that, move to the right. My right. Well, yeah. Okay. That's where you're going to have your parachutes, your drogue.
Yes.
Yes.
Okay. So does that section separate?
Pak tu dia pecah ke tak? Berpisah ke tak?
Oh. Is this separate?
Yeah.
This is the permanent.
This one.
Here, this is the one that separates from this to this. But this one is the permanent one to the screw switch. So we get like the separation point, this one,
Okay.
this one.
So it'll be separated to 3.
Yeah.
These
And
3.
this is the middle part.
Yeah.
And this part is going to be permanent.
So where you have your hands on right now, that section does not
Yeah.
separate?
This is the permanent screw down.
So where does your electronics bay go? Your recovery, where?
The avionics bay. Should be inside this one, inside this cover.
Right in the middle.
Right in the middle.
Slides in there.
Okay. This coupler is the avionics bay itself, so it's gonna be inside of this coupler. You can see this one. Can you fit it? Or
Okay.
do you want me to remove this coupler, the avionics bay coupler?
No. Maybe it's just me, but I don't quite follow. Or maybe I just can't. Maybe the video is really bad. So the airframe that's all the way to the right. Yeah. Move the camera the other way.
This one?
More towards. Yeah, that way. Stop. Okay. Where you got your hand, is that a coupler?
Yes.
That one.
This is
This is the coupler.
That's a coupler. Okay. Now it's beginning to make sense. Okay. So, all right. So to your left, well, to my left at least, back to that section by itself where okay. So, all right. Okay. Your electronics bay, your sending rings you're going to bolt those into the tubing, right? Into the airframe.
Yeah.
Okay. And then that, if I remember right, on each of the ends of those aluminum bulk plates will be your hard points where you will attach your harnesses and so on and so forth, right?
Yes.
Okay. All right. Okay. All right. What kind of payload are you using? Is there a payload at all involved in this?
Yeah.
Okay, so this would be our payload. So as you can see, the main chute's attachment is through an eye bolt of this payload. So the eye bolt, I'm not sure if you can see properly, but we have connected an aluminium part. It's an aluminium part that sandwiches the payload together with the bulkhead. So all of that is connected through this eye bolt. So later on, we're also going to drill holes here. Uh, it's attached already now, but we'll drill holes here to provide some additional support for this payload section. So that's how we are securing it to the rocket, and it goes inside this tube, this body tube. So this comes off, and then we're going to sandwich it in between the inside the nose cone. So there's a coupler in here, a nose cone coupler in here. You can remove it.
Yeah, hold this. You hold the.
When you while you're unscrewing things, when you come to the convention center for the final safety review, my suggestion is that the screws and bolts or whatever you're using, you don't necessarily tighten them all the way down, or you even leave them out so that it's easy to take apart, because they will request you to basically take the whole rocket apart. So same way with shear pins and so on and so forth.
This is. Okay. Where's this one? Wait.
More, just on the way, bro. Okay. So, all right. So, can you? Okay. So the payload bay will this is the payload bay and this is the bulkhead. So the bulkhead will be so first you saw those screws that attaches to the body tube, and then additionally we are planning to tap holes into the bulkhead itself and drill this into place. So
Someone's saying something. I can't hear anything.
oh, okay. So the bulkhead itself. So now we have the payload that's inside the nose cone, and then as you saw just now, the screw. We are screwing it to the body tube, and then additionally we are planning to drill a hole in the bulkhead itself and connect it to the body tube so that it doesn't move around during flight.
Okay, so okay, okay. So you're going to depend on. Okay, let me ask the first question. That nose cone is going to separate, correct or not?
No, no, no. Nose cone is not separating.
No, so it's not going to separate. Okay.
Yes. So
But
this tube and this tube is going to be screwed together also.
okay.
Yeah.
Okay.
Screwed.
Very good. Okay. All right. Now, so to anchor that bulk plate against that nose cone coupler, you're going to basically drill a couple of holes in that very thin bulk plate and hope that secures everything in place, correct?
Yes.
Uh, how, what is the thickness of that bulk plate?
This one is around 0.25 inches, so 6.35 mm.
So it's a quarter inch, half inch,
0.25 inch. Yeah, is that quarter? Yeah, I think. Yeah.
0. Point,
A quarter
so
inch.
it's quarter inch.
Yes.
What kind of bolts or screws or whatever? What size of bolts are you planning on using for that to hold it in place?
6 what?
6 2 mm bolts.
Okay.
Six.
How many of
6
them?
times 2 mm bolts. So 6 bolts.
Okay. All right. Rotate around just a little bit so I can see the connection going out to the shock cord. Do you plan on putting a swivel on that?
Do we plan? Are we putting a?
Pardon?
Do we plan on putting a swivel on this?
No. So in our current orientation, the swivel will only be will be located between at the connection between the parachute and the shock cord. But between the between the shock cord and the bulkheads themselves, we're planning on just using the quick links.
Okay. Okay. You're going to make for the final review, you're going to need to be able to discuss how you analyze the stress on that bulk plate, how you justified 6 holes and the size of the bolts, and so on and so forth, and the stresses on that. That looks pretty iffy to me.
Okay. Okay.
So you're gonna need to do your engineering homework and figure out that. I mean, I understand the strength of the aluminum bulk plate. What I don't like is dropping holes into it and then screwing into it when the size of the bolts or screws are probably going to take up at least half of that metal. So, I like I say, you need to do your homework and you're going to need to justify and that what you put together will hold up to the forces of the ejection charge and so on and so forth.
Okay, understood. Understood.
Okay. So we got some homework you need to do. Okay, so how are you going to turn the payload on?
The payload will be turned on through a switch at the side here. But currently
Okay,
there's
so
no
you
battery.
know,
It's just, but there's just a
okay,
switch.
we would prefer that when you take the rocket out to the launch site, you can't take the payload out.
Okay, so do you suggest us use an external screw switcher or?
Yes,
Okay,
that's what I would suggest.
all right.
You need a ladder too. It's all the way at the nose. It's going to be hard to access. Maybe you can have a remove before flight pin so that you're not trying to look through a hole. You can just rip it out, listen to it, and then call it good.
Okay, understood. Understood.
You can do that. And there will be ladders at the launch site. So I don't know the exact length of them. Probably 12-foot ladders. So yeah. And what kind of switches are on your switch band back on the airframe, back at your electronics band? Are there screw switches or what kind of switches do we have?
Yeah, they're all screw switches.
Okay, cool. All right. Okay. Um, Okay. Um, I think right now the potential problems I see are with that payload and securing it and making sure that it doesn't come out. Okay. This is only 10K, right? You're only going to 10K.
Yes, correct.
Okay. All right. So, I mean, the last thing we want is for that to come out and come flying down on the ground and hit somebody in the head or something. So, um, that's got to be very, very well secured in place um, on that. So, as far as that goes, okay. Um, okay. You could take advantage. Well, maybe not. Never mind. It depends on what your payload does and all that sort of stuff. Okay. Let's go back. Let me just take a look down the rocket and stuff. So, are you going to paint it?
Yes, we're planning to paint it, but at the moment it's not painted yet.
That's fine. That's fine. I don't care. The only reason I say is if you're going to paint it or not is that when you paint it, you lose all your marks.
Mm-hmm.
So be aware of that. Also, review the contest requirements for lettering and team numbers and all that sort of stuff that need to be on the rocket in the appropriate places. Okay.
Mm-hmm.
And the other thing that you need to do after you get your painting all that done is mark the center of pressure.
Okay, understood.
Okay. We don't need to worry about center of gravity. We do need the center of pressure marked for us. Okay. Let me see here. You responded back to my questions about slow rail exits and stability and all that sort of stuff. That's okay. I'm not sure an 8-mile-an-hour wind is going to cover Texas. It's going to cover that part of Texas. Winds are probably more like 12 to 15. So you may want to keep that in mind. Let me think here. Your stability is a little bit low, but that should be fine. What is your descent rate under drogue?
It will be around 100 feet per second on the drogue.
Okay. Around being like between 95 and 100 or between 80 and 100?
Between 95 and 100.
Okay, good. Good. We want to get you down as fast as we can. And what altitude are you going to deploy your main?
1,500 feet.
1,500. Okay. All right.
Yeah.
Sounds good. And you have, according to your report 3, done compression testing on your tubes, and correct?
Yes.
Okay. And you've done your battery. Have you done your battery drain testing yet?
Sorry?
Have you done your battery drain testing yet? See how long your batteries will last?
Yeah, we'll be doing it to double check it, the drain, how long it takes to drain. We haven't do it yet.
Okay. It's on your list. You got a lot to do. Okay. Go on
Do you
ahead.
have any glass protector for your shock cord? Your shock cord's not Kevlar, right?
Yes, the shock cord themselves are not Kevlar, they're just nylon. So what we are planning on doing, as you can see here, yeah, on the ends that are connected to the avionics bulkhead, which will be like the most exposed towards the explosive charges, right? We'll be covering them with this the Nomex fabric, something like this, just to provide more.
Or you're just gonna wrap around it?
Yes, just wrap around the
Okay.
shock cord.
Yep.
Okay. That's good policy to do. Okay. Okay. I'll summarize it this way. Your rocket's not complete yet. You're still working on it. You got a fair amount of stuff to do yet. It's all nitty gritty stuff more than anything else. I don't see anything structural other than the fact you haven't got your pins mounted yet. So depending on how you do that, that may or may not be a structural problem. Again, I'm concerned about the payload, how you're going to secure that bulk plate to make sure the payload doesn't come out and fall down. Okay. Obviously, on the electronics bay, securing of the batteries is extremely important. Cleaning up the wiring is also important on that end of it. So, and when we ask the team's question, what experience does a team have flying this level of a rocket?
Hello. Okay. Yeah. So our team previously we have experience in smaller level tournaments, but at this scale, this is our first time.
How small?
Okay, so is this the first rocket of this size that the team has flown?
Yes.
Okay, what size of rockets did you fly before?
Oh. So previously, our team has just experience with small scale rockets for like university projects, but that's about it. The rocket size is less than
diameter,
like around
motor.
2 feet.
2 feet.
Yeah, around 2 feet. It's a small rocket.
Okay. At least you got some experience. You have to do ground testing.
Yes.
Whether you have to do it twice, I'll let you guys decide that when you get to the States. You will have the ability at the launch site to do that. Well, we've always provided for ground testing, so that won't be a problem.
Do you want to set up another review once they actually fixed everything together, or is email enough?
And it's getting kind of late for that, and my calendar's booked. So, I mean, I think you need to do that. Okay.
Yeah, I will.
As the FOR, you definitely need to do that.
It's not ready. I won't fly it, so I'll make sure that's all that's done.
At this stage of the game, I'll take. I'll take your word for it. You've interacted very well. A lot of the FORs would just sit there and be mum. Okay. I appreciate the comments and the follow through. So I think that's probably something that you should probably do before they leave stateside. on that end of it. So, okay, I'll make a couple of comments about the contest. Number one, if you were there last year, you know that we had these great big tents, commercial size tents installed. That will be there this year also, along with all the support facilities that go along with that. We are in a desert. Expect temperatures to be in the high 90s most of the day. It's going to be windy to a certain extent. It won't be probably as bad as New Mexico was, but it's still the desert type of thing. There are really good information on our websites about clothing and hydration, and all that sort of stuff that you need to do. Again, keep in mind it is the desert and it is going to be warm, so you need to dress appropriately, especially for those that are going out for recovery. On that end of it. So, don't recovery, for instance, don't wear tennis shoes because you'll probably put spikes through your tennis shoes. Wear good solid good solid shoes, hiking shoes, that sort of stuff on the end of it. So, where are you staying at? Are you staying in Midland, Texas?
We'll be staying near Pecos.
I'm sorry, I missed.
Pecos? Is that how you call it?
Oh, okay, cool. That's where my team is staying also, is Pecos, which is in the middle. So you got an hour, maybe a little more than an hour drive to the launch site, maybe a little more than an hour drive to Midland. Then that's very good because Midland is basically the convention area, and the launch site is about 2.5 hours from Midland. So Pecos is a good place to. It's kind of in the middle. So okay, cool. Okay, I will reverse the table. And are there any questions that you would like to ask me that I can help you out with?
Actually, school future. Do you want to ask regarding the? No? Okay. So far, it's just regarding the payload, I guess, because what we were thinking of is just securing using this, but additionally, maybe we were thinking of like putting another centering ring and through to the nose cone. So is that a viable?
Mm-hmm.
Yeah, or like maybe an all thread or something to through the nose cone.
Yeah, yeah. I was going to, yes. That thought went through my mind. Depending on your payload and what's inside, you may be able to take advantage of the all thread coming off the nose cone tip.
Yeah, is there anything going
And
in the
anchoring
middle
that
of your
even better
payload?
and straight. Yeah, but it depends on the payload.
Yeah.
Yeah, the payload will have a closure here, so there's just going to be a thick aluminum plate here, so maybe we can just
But
drill.
the thread itself, like from the nose until the cap of the payload, not like all the way
Good.
through.
I like the thinking. Yep. Any way that you can secure that, better off will be.
If we cannot like get it all the way through, just we make a cap for this and like at least to get inside a little bit or make a specialized shape to try to get.
There are no PCBs that you are stacking all the way down, right? You can put an all thread through the entire CubeSat, right?
No, there's PCBs in the middle of the.
Oh, then you can't use an all thread. Then
So,
go
Well,
with
they
the
could.
additional centering.
Yeah, I mean, they could come up with a way of on the top there and tapping into the all thread. So there are some ways to do it. So, but I think it needs to be more solid than what you're talking about. So any way you can come up with would be great, I think, on that end of it. So, okay. Like I said, to me, the major areas are the payload, securing of the payload, electronics, battery securing, so on and so forth, establishing of the fins, and how they're glued in place and all that sort of stuff. So a little bit of work to do. You're in better shape than what I've seen some other projects. So, but you do have work to do. So, okay. Again, any questions for me, or you? And I assume everybody's been registering and you've got all that out of the way.
Yeah. Also, a question regarding the payload. Would it be better to not to just make this smaller to fit inside the coupler? So we like push it and this bulkhead go through the coupler, and if we make it like a little bit bigger, like 0.375, and we screw it directly with the same screw to the nose cone shoulder, to the tube, to the bulkhead altogether.
Yes, because if you put that tube on, you're gonna have to reach your hand all the way on the inside, right?
Yeah.
Just to load the payload.
Yeah, then we just like connect all the three together at like with the same bolt configuration.
If you put it on the coupler, you have to make sure that whatever screws that you're using is flush with the coupler, because if they are protruding out of the coupler, you're not going to be able to insert it.
Oh yeah.
Right. So and depending on how thick your coupler is, you know, if your coupler is really thin, whatever screw that you're using is not going to have enough material to bite onto it.
Yeah.
I still think the best way is if you put if you secure a centering ring further up the payload. That's, you know, that way you can just pin it through the side of the nose cone itself. That's what I do.
Yeah.
So we drill holes through the nose cone, or?
Yeah, the nose cone is
through the side of the nose cone. You know, the straight portion.
Yeah, it's possible.
Like where the coupler slides up into the nose cone, that section.
Yeah.
Okay.
Yeah. Then you have the nose cone and the coupler giving you extra thickness, right? You don't have to care about anything sliding in or out.
Yeah. Okay.
Yeah. There are several alternatives to how you secure that payload, and again, don't forget you need to be able to turn it on externally, not take it apart at the launch site and put it back together again. So, okay.
How do you know if it's on?
There's a display. There's a display here to show like battery level and
But you won't see that if it's already enclosed in the nose cone. So
yes.
Are you gonna have a big hole? To throw a buzzer in there, that way you can hear it. It's gonna be super bright. You might not see it.
I think we need. Yeah, I think you guys need to discuss that and fin attachments and all the other stuff that I mentioned. So I'll leave that up to your FOR to consult you on that. So okay, again, if anybody have any questions for me, if not, I think we can go ahead and turn it off. And I'll just make one more comment, and that is that this video the recording needs to be turned off, and you need to take the video and put it up on a shareable drive and send an email to general.info@esrarockets.org.
Okay, all right, will do.
With a link to the video.
Will do.
Okay. Guys, overall, I think pretty good. You got some work to do. That's not uncommon. I think the concepts are pretty good. The FOR, you listen to him. He's got a lot of good advice coming down the pipe. So I can't think of anything else. I look forward to seeing you in Texas in a few weeks, and wish you all the luck.
Okay. Thank you very much, Mr. Ben. Thank you, Julian.
Okay. And if you have any questions or anything else, you got my email, so just zip them off, and we'll see you in Texas.
All right. Thank you very much.
Thank you, sir. Everybody have a good day.
Okay. Thank you. You too. Have a good day.
Okay. Bye-bye.
Bye.
Bye.